Hey, good morning, everyone.
Morning. Morning.
Welcome to our lecture today. As a quick revision, we know that we have two types of medium access control: control techniques and random techniques. Control techniques, we prefer to use them in cellular architectures. In architectures that require heavy signal processing, resource allocation, and have the capabilities to do this. So, control medium access in cellular. Random access, we use random access techniques to provide flexibility to the network. So it will be used in the local area networks, Wi-Fi networks, something like that. And as I told you, random access is preferred to use in Wi-Fi. Wi-Fi is used to provide a communication within slightly small areas with a small power, short distance, and we divided the spectrum into two types: free spectrum and licensed spectrum. Free spectrum is used in Wi-Fi, microwave, Bluetooth, Zigbee, remote control of your TV, and in many applications. Okay, so in random access, in order to provide flexibility to the network, as we know, so many devices can share the same channel, can transmit at the same channel. But if we have two devices transmit at the same time, we will have collision. So at first, via Daniel 1, Daniel 2, okay? So Daniel 1 has a packet or frame to transmit. So Daniel will transmit the packet without any coordination with all other users at full data rate. This is my channel, I will transmit, okay? Daniel 2 has also a frame to transmit. So will transmit at the full channel data rate without any coordinations with any other user. What will happen? This is the channel. This is Daniel 1 frame, and this is Daniel 2 frame. What will happen? We'll have collision. Total loss. Okay. If two frames have collision, this means that the two frames will be destroyed, will be lost. So the transmitter must retransmit their data again. So what we need, as we have, what is the problem here? We have collision. This is the problem. Okay. How can we solve this problem? We need two techniques. We need, if we can have collision avoidance technique and collision recovery, and we also need collision detection. So we have collision. We must be able at first to detect that we have collision. Okay. After that, okay, we must to recover from, so okay, so this, we must recover from this collision. We must repair what happened in collision. We must repair this collision by retransmitting this data again. Okay, this is the first version of random access techniques. They detect that we have errors, and I will help you to recover. Okay. In the advanced techniques, no, I want from you to avoid collision. I don't want to have accident here in this route, in this channel. I want from you to avoid, to prevent all the collisions. So at the beginning of random access techniques, they were built on the idea of we can detect collisions and we will help you to recover from this collision. But they will not prevent collision. They will try to minimize the collision as much as we can, but still we may have collisions. In the advanced techniques, no, we want to prevent collision. We want to avoid collisions. Okay, so this is the basic idea of random access techniques. The main problem is collisions and how we can overcome this collision. Recover or avoid. Okay, so the first protocol is ALOHA, and this is the simplest protocol. Okay, and this is one of the first versions of random access techniques. We consider it as the father of the multiple access protocols. Okay, in ALOHA, it is suitable for networks where users are competing for use of single shared channel. Okay, ALOHA can divide it to two types: pure ALOHA and slotted ALOHA. In pure ALOHA, the basic idea: each user transmit whenever they have data to send. Once you have frame you want to send, transmit. As I told you, there is no any coordination with other users in the same network. No. Once I have frame, I transmit. I consider this channel is my channel, my own channel, and I must transmit at any time. Okay. So if two devices transmit at the same time, so frames will have collisions. Collision means lost or destroyed. So how sender can detect in ALOHA that we have collision? Through two techniques. The first one is by receiving feedback from the channel. If we receive acknowledgement that our packet is received, this means that our packet is okay, everything is nice, yeah, and it is a sunny day, yeah. If we don't receive acknowledgement for certain round trip time, this means that our frame, we consider it as our frame is lost. Okay, this is the first technique. The second technique, by sensing the channel. What happens if two cars collide, have collision with each other? We may have explosion. Yeah, this may happen. Yeah, okay. So this may happen. Yeah, in transmission over electromagnetic waves, this also happens when two frames collide each other. The electromagnetic power increase as a result of the fire or explosion. You can imagine it as the same way. Okay, so if the electric voltage over the channel is in either case, this means that everything is okay, the transmission is okay, no collision. But if we sense the electromagnetic energy and find that the electromagnetic energy started to increase, this means that, oh, we have collision here in this channel. Okay, so how can we detect? Okay, and as a quick revision for Brendan, we are speaking about pure ALOHA. As I told you in the previous lecture, in ALOHA, when you have data to transmit, there is no any coordination with any other user in the network. You transmit at your full rate. You transmit. You consider this channel as your own channel. Okay. If two devices transmit at the same time, we will have collision. And if frames have collisions, we consider it as destroyed or lost. How we can detect the collision? As I told you, through feedback or receiving acknowledgement or not, or through listening to the channel, sense the channel. You understand what is the meaning of listening to channel? To try to sense the electromagnetic energy at the same time. If we have collision, it's like we have explosion. So the energy will increase. So all the devices will detect that we have collision here. Okay. If the amount of electromagnetic energy is steady or in either case, this means that everything is okay. So as I told you, how can we recover? So we have the problem now, collision. How can we recover? You will wait, Daniel 1. You will wait for random time. You will decide, I will wait for 3 seconds and will transmit again. Daniel 2 will say, I will wait for 7 seconds and will transmit again. And the reason that we say random time, you wait random time, as if all the users wait for fixed time, we will retransmit again at the same time, and we will again have collision. Okay, so as you can see here from this figure explains the transmission of frames in pure ALOHA. As you can see, each station or each device transmit when it has frame to transmit. So at this time, this is the time scale, as you can see. At this time, I want to transmit frame 1. I have frame 1, I will transmit it. At this time, I have frame 2, I will transmit it. So once you have a frame ready to transmit. Okay. As you can see here, we have this duration is collision duration. So frame 1 will be received in a successful way. No collision. Correct or not? What about frame 1, 2, 2, 1, 3, 1, 4, 1? Collision. And the collision will happen if your last bit, if your frame is transmitted at the same time of my first bit, this collision, and we consider it as total loss of the frame. Can you imagine this? Total, the insurance, communication networks insurance will consider it total loss. Okay, as you can see here. So this frame, the start of this frame is here. So collision. Okay, as it will collide with this bits. Okay, this collision. Okay, and as we can see here also, frame 2.2 and frame 4.2 will have collisions with each other. What about frame 3.2? It's okay. So that's why we have lots of collision. The probability of collision in pure ALOHA is very large. It's very large. Let's discuss the flow chart of pure ALOHA to understand more the process. Okay. Oh, need to zoom. It's clear to you? Yeah. Okay. So at first, start, set back off to 0. Back off means that the number of retransmission. So this is my first time. I will set it to 0. And I have frame transmit. And after I transmit my packet or frame, I will wait. Wait for what? Wait for receiving acknowledgement. Received acknowledgement? Yes. So your process is successful. Your packet is received. What if I didn't receive acknowledgement? No. This means that we have a problem here. We have a collision. Okay. So I will increment my backoff time as I will need to retransmit. Okay.
Collisions on the acknowledgement message as well.
Can the collision be on what?
On the acknowledgement message.
In the acknowledgement, yes. Yeah, as we have two-way communication. Yeah. So as I told you before, that we didn't receive, we may not receive the acknowledgement because of collisions. Okay, so the collision may happen as an acknowledgement also. Yes, that's correct. So increment back off. This means that at first I have back off with 0. So I will increment it to B1, which means that I will retransmit this packet again. How many times should I retransmit my packets? Should I go in infinite loop? Yeah, retransmit. No acknowledgement, retransmit. No acknowledgement, retransmit again. Till infinity? No. You must understand that now we have a problem in the channel. Yeah. So you must all stop from sending any packet over this channel now, as we have a problem. Okay. So in the system administrator will set the limit of the number of retransmission. The default number is 4 times. Okay. This is
For what?
4 times, four retransmission time. Yeah. So you will retransmit your packet for first time, collision, second time, collision, third time, collision, fourth time, collision, stop. You must understand now that we have a problem in the channel. We must stop. Yeah. So that's why we set a parameters that can measure how many retransmissions occur over the channel. Okay, so at first it's 0. Here, if our packet is received in correct way, success. Okay, 0. If no received acknowledgement, we will increment the backoff by 1. Okay, and check. Did we reach the limit? Yes. Okay, stop. No. Okay, so I will adjust myself to wait random backoff time. This and return back to send my packet. Okay, so what will happen? We have 2 cases here. The first case is my packet is received successfully. Okay, how if I received acknowledgement? No. Okay, so I will wait for backoff time, random backoff time. Remember this backoff time is random. So after my backoff time random finished, I will send it and check again if the packet is received. Okay. No, I will wait for another random backoff time, and so on until my packet is received successfully or I reach to the limit of the packet. Okay, this is the basic idea of pure ALOHA. Okay.
So with this system, how many users can this usually support? Because the more users you have, the higher your percentage chance of collision is going to come. So eventually you're going to get to a point where you have so many people transmitting on a random basis that it's going to get lost over and over and over again.
Yeah, for sure, this is a correct conclusion. As the number of users increase, the probability of collisions will increase, and we will may enter an infinite loop of retransmissions and collisions and something like that. So pure ALOHA, okay, is not efficient technique, not efficient, and we will see in the throughput of pure ALOHA, you will find that the total throughput will be very low. Okay, but again, remember, pure ALOHA was developed in 1970. The number of users, number of devices at this era was slightly small. The number of communicating devices also was small. We are unable to use pure ALOHA now in our communication network. And you will see by the end of random access, you will understand what is the technique used now in Wi-Fi. And you will compare it with ALOHA. So in order to understand what we have now, you must understand the history. So yeah, we have ALOHA, we have slot ALOHA. After that, we will move to carrier sense multiple access. And the carrier sense multiple access has 2 techniques, collision detection and collision avoidance, and many types. So why? Because sometimes now in the 5G and 6G, we sometimes face problems and we find the solution in the old techniques. Not exact way, but we can take the idea and modify this idea. So that's why in engineering, you must know the journey. Yeah, so for example, if I explain to you in my first lecture 5G, will you understand? But if I start by 1G, 2G, 3G, 4G, and 5G, you will understand. As by development, the scheme becomes more complex in understanding. But as you can see here, in pure ALOHA, it's a very simple scheme. You want to transmit a frame, transmit. This is the simplest way of thinking, but you will have collision. What if you have collision? Wait random time and repeat again. This is the very basic idea. Okay, so that's why we study pure ALOHA, and after that, we will see the development of pure ALOHA. Okay, by using student ALOHA. This will allow you to learn, following the same way. If you are working in certain technique, follow the same way of thinking of development. You can develop your own technique also. Okay, so that's why we must go from with the journey from the start to the end to understand the complete idea. So I know you are correct. ALOHA can't support large number of users, but again, in 1970, we don't have large number of users. Okay,
So the setback off.
Yeah.
That I think of that as like a list that has what packet was transmitted and didn't make it, and like it's like a list of the packets that we need to try and retransmit, or is it just a number that says we need to try and retransmit 7 packets?
okay. Setback of this number is associated with certain frame. So you have one frame to transmit. Okay, so start, and this process explains the transmission of one frame. Okay, so you have one frame. I will start setback of to 0. Okay, as this is my first transmission try. Okay, and I will send my frame. What if I have second frame to transmit? So you will start from the beginning. Then setback of to 0 and go on. So
So it's like one at a time. Like if the first one doesn't make it, we're not sending the second one. We're going to wait until we get the first one.
yes.
Okay.
Okay.
So the setback log can never be more than 1, right?
Setback of at first.
Yeah, okay, I get it first, like it's 0, but then
It's 0. After that, we will increment if we have collision, so we'll increment the backoff time here.
sure, yeah, I think.
But as you can see, when we return back, we don't return back to the initial value. We return back to same data. As your backoff time now is 1, backoff value is 1. So again, we start 0. At collision, increment backoff. The value of backoff 1. Wait random time, send data.
Okay, I see that.
Okay, collision, increment backoff, it is 2. This is your second try. Okay, and at each time we check, we reach to the limit of number of retransmission or not. Okay.
Thank you.
You are welcome. Okay, before we start, how we can minimize the collision in pure ALOHA? So in order to have successful transmission, what should we have?
Don't have people sending at the same time.
How can we guarantee this? So
like random time to some sort of positive time.
Like only allow certain people to transmit at certain.
let's make the discussion more effective. Okay, so in terms of time, okay, how many seconds you need to ensure that your transmission is correct?
Couple, I don't know,
Depends on the transmission.
You said couples of what?
couple of seconds, a couple, well, actually, I guess, for back off times, or for.
Okay, and then
I mean, it depends on the packet size. If you're sending a frame that's huge, you're gonna have a longer time that you need to send.
assume that all the frames have the same size. Okay, and we can consider the frame time is TF. This is the transmission time of frame. Okay. So in order to transmit one frame, we need TF seconds. Okay. Okay. How many TF seconds we need to ensure that we have successful transmission?
We'd have to wait for a previous frame to finish transmitting and then the time required to transmit our frame.
So the total
That'd be 2 TF.
2 TF. Any other answer? You agree with Duncan? Agree?
Yeah, I like it. I think we
You like
it.
Yeah. Perfect, Duncan. This is correct answer. Okay. So we must measure metric called vulnerable time. Okay. So as you can see here, this is our frame. Frame A, this is our frame. And we want to ensure that this frame to be transmitted in a successful time. So at first, we don't want anyone to transmit in the frame time, the frame transmission time. So from T to T plus T frame, TF, okay? So let's assume at first the frame time is TF, okay? So at first, during this duration or period, we don't want anyone to transmit, okay? And also to ensure that no one can collide with me, we don't want any barrier transmission before my start of transmission with TF also. So I want to empty this period and I want to empty this period in order to ensure that we will not have any collision. Okay, so the vulnerable time equal to 2 multiplied by the frame transmission time. Okay, so Duncan has correct answer, and we can discuss this example. We have a pure ALOHA network. We transmit 200 bits on shared channel of the data rate of the channel 200 kilobit per second. Okay, so what is the requirement to make this frame collision free? Okay, so at first I want to calculate the transmission time for the frame. So our frame consists of 200 bits and will be transmitted over a link with data rate 200 kilobit per second. So the transmission time TF will equal 1 millisecond. Okay, so what is the requirement to make this frame collision free? So we need the vulnerable time to be 2 multiplied by the frame transmission time. So 2 multiplied by 1 millisecond. So we have 2 milliseconds. This means that no station, no user should send later than 1 millisecond before my start of transmission, and no station should start sending during my period of transmission. This is the meaning. I don't want any station to send later than 1 millisecond, which is the TF, the transmission, the frame transmission time, okay, before my start of transmission, and also don't want anyone to share the channel at the same time I transmit during my period of transmission. So that's why, in order to ensure that we have frame collision free, we must have free transmission, no transmissions during T2 multiplied by transmission frame, double of the transmission, the frame transmission time. This clear to you? Okay, okay. So turn back to the conclusion of Brendan and let's calculate the throughput of pure ALOHA. Okay, so let TF be the frame time. Okay, and which is the time required for 1 frame to be transmitted. And let G be the number of transmission attempts per frame time, the arrival time at each frame transmission time. We want to measure the arrival times, the number of users that try to transmit their data on the same time. So the probability that we have k frames generated during the frame time, we can model it using the Gaussian distribution. Using this is the formula of Gaussian distribution, which consists of G. G is the transmission activities, the arrival rate, and K is the number of the frames generated during the transmission time. Okay, we can measure the probability of the K frames generated during the transmission time using Gaussian distribution. From this formula, suppose that we have 0 frames generated. As if we want to have successful transmission, we need to have 0 frames generated. Yeah. Okay. During the transmission frame transmission time. So we can say that the probability of 0 frames generated, can anyone calculate it? We will set K by 0. So G power 0 is 1. K 0 factorial 1, 0 factorial is equal to 1. So the result is the probability that we have successful transmission, which is the probability of 0 frames generated during the frame time, is equal to E minus G, exponential minus G. Okay, but in pure ALOHA, the vulnerable time period is equal to 2TF. Yeah. So if I told you the arrival rate in time TF, the arrival rate is G. Okay. In 2TF, what is the arrival rate? 2G. Yeah, it's very simple. Yeah. So again, we have frame time, okay, TF, which is the time required for one frame to be transmitted. And we have G. G is the arrival rate, okay, during this transmission time. We can calculate the number of K frames arrived or initiated at the frame transmission time using Gaussian distribution, using this formula. I want to know what is the probability of having successful transmission. How can I calculate it? By setting K to equal 0. I don't want any other frame to be generated during this time. So by setting K with 0, I have the probability of success, probability that 0 frames generated during the frame time. This would be equal 1, this one. So my probability of success would be E minus G. Okay. But in pure ALOHA, I have my vulnerable time to equal to transmission time. So I have this formula was for one frame transmission time. Okay. So, but in pure ALOHA, I have my vulnerable time equal to 2 frame transmission time. Okay. So my load must equal 2G. Okay. So the probability of success, instead of having E minus G, it must be E minus 2G. Okay. Why E minus 2G? Because the vulnerable time in pure ALOHA equal to 2 frame transmission times. So if I have load G for 1 TF, for 2 TF, the load must be 2G. Okay, so this is linear relation. Okay, so the probability of success must be E minus 2G. And in order to be able to calculate the total throughput, I must multiply the arrival rate, okay, by the probability of success. So the throughput can be calculated as G multiplied by exponential minus 2g. Let's see this example to understand more. We have a pure ALOHA network transmits 200 bit frames on shared channel of 200 kilobit per second. The same example, okay, as we have. What is the throughput? If the system, all stations together produce 100 frames per second. 1,000. Thank you. Okay. So at first, we must calculate the frame transmission time. How can we calculate the frame transmission time? The frame transmission time is equal to the number of bits per frame divided by the total data rate. As in pure ALOHA, as I told you, you will transmit at the full data rate of the channel. So this equal to 1 millisecond. Okay, so the TF, the time to transmit one frame, equal to 1 millisecond. And all the stations, all the users produce 1,000 frames per second, which means that we produce 1 frame per 1 millisecond. Yeah, so the load G, okay, equal to 1. Okay, the load G equal to 1. We can calculate the throughput by multiplying our load by the probability of success. So G exponential minus 2G and G equal to 1. Calculate this equation, we will have our throughput will equal to 13.5%. Only 135 frame will be received without any collision. So from 1,000, can you see? From 1,000 frame, only 135. Imagine that if we have 1,000 students in this class and only 135 students passed this course, not failed in this course. What will you say?
We need a new professor.
So instead of professor, ALOHA. Okay. Okay.
Can you go over again just how you got G?
Okay. So G is the arrival rate. Okay. So we generate 1,000 frames per second. Okay. So and our transmission time, the transmission time is 1 millisecond. Okay. So and 100 frames per second means that we generate also 1 frame every 1 millisecond. Okay, so at every millisecond, 1 millisecond, okay, we generate 1 frame and we able to transmit 1 frame. Okay, so the load here is 1. Okay, the load here is 1. As I have in every 1 millisecond, okay, I can transmit 1 frame and I can generate 1 frame. Okay, so the load is 1. Okay, so it is very direct. You are interested to find the value of G. Okay, when you find the value of G, you can calculate the throughput. As you can see, pure ALOHA is not efficient in case of we have lots of users. As 1,000 frames per second means that we have lots of users. Okay, we can say that each user will generate 1 frame, so we have 1,000 users. So from this 1,000, only 135 successful transmission, around 13.5% low efficient technique. So it is not suitable for large networks, but it is the simplest scheme. We don't have any complexity in this scheme. Okay. Okay. So in next lecture, we will discuss how can we improve the performance of ALOHA by proposing improvement over ALOHA called slotted ALOHA. 'ALOHA. Okay, I know you have midterm exam. you have enough time to prepare for it. Wash your face, yeah, and yeah, no tears, no tears. Don't worry.
Okay.
You can do it, and you will get the full mark. Yeah,
Oh, really?
Yeah.
Full mark.
full mark.
Just like
Yeah.
you did on yours, right?
My students must get the full mark
Don't
Yeah.
tell me how good.
in all subjects. Okay.
Yeah.
So we will stop today, as you will have midterm exam. Enjoy your day, and see you 1 week.
We're gonna have a lab the first Monday back.
No, so okay, so we really have a problem in the lab, as the Thanksgiving was on our Monday, and reading week is on our Monday. So till now you have only 3 labs, okay, and we must finish 6 labs.
6?
6. I sent message to the School of Engineering to try to make them only 5, okay, but if we will have 6 labs, the last one will be very easy. Okay, don't worry about this. So I'm waiting their response of School of Engineering, as it is our luck to have Thanksgiving and reading week on our Monday. So once I receive feedback or response from School of Engineering, I will let you know. The level of all of the coming labs will be very easy. Don't worry about this. So yeah, we will handle it. Don't worry about this.
Like no lab for the first 2 labs.
No, we'll wait. I think to
The next Monday after?
yeah, as next Monday during reading week is our Monday. Okay, it's off. Okay, 15 November. This is their lab. The other subjects. Okay, so we will have our 4th lab in 22 November.
Have you tried contacting the other class? Because maybe they, like, I know sometimes professors just like bump their lab section back, or like if ours was the 15th, they might assume that we get the 22nd.
No. I asked the School of Engineering about this, and they told me that your next lab will be in 22 November. Okay. So we will discuss it after we return back from the reading week. Don't worry about this. Focus on your midterm exam. Okay.
Thank you. Have a nice break.
Yeah. You too. Hello. Hello, Brad. Hello, Thomas.
Yes.
Yeah.
And that's not being heard of.